If you've ever struggled with DAX and Power BI, well, you're human. DAX is not easy. In this video, we're going to look at how to use DAX to create calculated columns and measures. And while we're at it, we'll dig into row context and filter context. Here, we're analyzing a freelancer's business to see if we can find some low-hanging fruit to improve their bottom line. And we'll need to use DAX to do it. If we take a quick look at the data, we can see that the business is paying fees to receive some payments from clients. Let's find out how much is going out the door in fees. Over on our report, before we start writing any DAX, we'll start by creating a table visual that shows payment method and fee rate to get a quick overview. Let's convert the rate to a percentage. This tells us that the only payment method with a fee is PayPal. Clearly that rate is too high. We know for sure PayPal doesn't charge a 55% fee. So why is Power BI showing us that number? If we right-click on the field in the Visualizations pane, we see the Power BI automatically set the field to sum. Since this is a percentage rate, it's a non-additive number, which means we don't want it to sum. Now we could just click Don't Summarize here, but if we create another visual and add the field there, Power BI will automatically sum it there again. Let's change it so that Power BI doesn't automatically sum fee rate when we add it to a visual going forward. With the column selected in the Fields pane, in the Column Tools tab, set the summarization dropdown to Don't Summarize. The first thing we see is that Power BI changed the column name to Sum of Fee Rate. That's helpful, but I really don't know why Power BI doesn't add the words sum of every time a column is auto-summed, rather than only when we change a field to Don't Summarize. Especially for a newer Power BI user, it's easy to forget that Power BI automatically aggregates numerical fields. Let's remove the fee rate column, then add it to our table again. We see that Power BI didn't auto-sum it this time, and now the PayPal fee rate looks correct. With that out of the way, we can get back to what we really want to know, which is how much the business is paying in fees. If we switch to our data view and look at the income table, we have the income amount and the fee rate, but we don't have a column showing us the fee amount. In order to get that number, we'll need to add a calculated column. Calculated columns are a way to extend a table by adding columns. To create a calculated column, click New Column. Then in the formula bar, we'll enter fee equals amount times fee rate. In this formula, also called an expression, fee is the name of the column, and we're just telling Power BI we want the result of amount from the income table multiplied by the fee rate from the income table. To finish, we can just click Enter or click the check mark. Let's take a look at our new fee column. What happened is that Power BI went row by row and performed the calculation for our new column. It took this value, multiplied it by this value, and put the result here, and the same for this row, and for every row in the income table. In other words, for a calculated column, the values that Power BI plugs into the expression are the values in the same row. This is something called row context. Whenever we hear a new term, it can be hard to grasp its meaning right away. Another way to think of row context would be to replace the word context with awareness. So when we say the calculated column has a row context, that means the expression is only aware of the values in the row. It can only see what's in the row. It can't see anything in any other rows, and it can't see anything else in the report. It has no awareness of filters or slicers or any other visual in the report. The technical reason for this is that calculated columns are pre-computed when the data is refreshed, and the results of those calculations are stored in the data model. Because the data refresh happens before the report is rendered, calculated columns have no awareness of the report and cannot be affected or changed by anything on the report page. Row context is one of the most important concepts to understand in Power BI, and we'll come back to it a little later in this video. Okay, let's see what happens now when we add our new calculated column to the report. We'll switch back to our report view and drag our new fee column onto the table visual. And that shows us the business is paying more than $5,600 in fees. Now, even though we just said that a calculated column calculates expressions row by row, and we saw in the data view there were many rows that were calculated, here we're only seeing a single row. Why is that happening? If we right-click on the column in the Visualizations pane, we see that again Power BI automatically set the column to sum. This auto-sum setting is on a column-by-column basis, so the change we made earlier was only for the fee rate column. Here in our fee column, it makes sense to leave the auto-sum feature turned on. But let's temporarily change it to Don't Summarize so we can understand how Power BI presents our data. Here, it looks like Power BI just gives us a list of all the individual fee amounts. The problem is, that's not what we're really seeing. We can tell because we saw earlier that the fee total was over $5,600, but here, doing some quick mental addition, the numbers in our fee column look like they add up to less than $5,000. The reason is that in the table visual, Power BI consolidates the data so it doesn't show duplicate rows. In this way, table visuals in Power BI are very different from the base tables that make up the data model. The base tables contain all of the raw data stored row by row, but a table visual is designed to show a consolidated view of the data. When we take a closer look at the fee column, we see there's only one of each fee amount. There are no duplicate amounts. But if we add the date field to the table, now we see there are more than one of some of the fee amounts. They just occur on different dates. And that's really the reason why Power BI auto-sums numerical fields by default in a table visual. Otherwise, depending on what columns we choose for a table visual, the results could be confusing or even misleading. Let's get rid of the date column and turn on sum again for the fee column. We've seen that in this case, the auto-sum feature actually works well to represent our total fees in a table visual. But what if we need to use total fees in a DAX expression? For example, we'd like to calculate the total fees as a percentage of total income. That would give us a better picture of how much the fees are eating into the bottom line. Well, we could try to do that by creating a new calculated column. In DAX, we have the sum function that allows us to calculate a sum. Let's try that. We'll click the income table, then the new column button. And let's call this fee sum equals, then we use the sum function, and then we want to multiply amount times fee rate. When we close the parentheses, we see a squiggly red line. This means there's an error. If we hover over the line, Power BI tells us the error. Parameter is not the correct type. If we take a quick look at the documentation, we can see that sum only accepts a single column. In our DAX expression, we're trying to multiply two columns together. That won't work. We could change it to enclose each column in a sum function. That fixes the error, but that's not really what we want. We've already said we don't want to sum the fee rate because as a percentage rate, it's a non-additive number. Instead, what if we try removing sum from fee rate? Well, that gets rid of the error, and that feels a little closer to what we want. So let's add that to our table. Those fees are way too high. What's going on? One way to troubleshoot DAX is to try to take a look at it from a few different angles. To do that, let's get rid of payment method in our table visual, and then let's add client and amount. This tells us that more than half of the income is going to fees. Wow, we're way off. Let's check if it's auto summing. Well, this could be part of the problem. Let's set that to don't summarize. Now we're seeing that the fee sum is exactly the same, no matter what amount we have. And our fee sum column doesn't match our fee column, so that's not right either. Whenever it starts to feel like we keep hitting a dead end when working with DAX, it can be helpful to break up the DAX expression into smaller pieces so we can see what's going on in one piece at a time. Here, let's create a new calculated column that contains just the first part of our expression. We'll simply write income sum equals sum of amount. Let's add that to our table, then set it to don't summarize. This shows us that every row is the same number, and this number is equal to the total of our income amount column. In other words, a grand total of all income. And now we can see that our expression fee sum is just multiplying this grand total by the fee rate, and that's giving us the number we see in the fee sum column. That's why we're not getting the numbers we want. What we want is for the values in our fee sum column to match the values in our fee column. So now that we see that income sum is the problem, we need to understand why it's just showing the same grand total of income in every line. To figure out the answer, we need to understand how the sum function works. Sum is what's called an aggregate function. Aggregate functions aggregate data for all the rows in a column. When an aggregate function is aggregating data, first it applies any filters that are in place on the report, because filters can reduce the rows in a column. The set of filters that are in place on a report is called the filter context. But a calculated column has no awareness of filters, because as we said earlier, a calculated column is pre-computed before the report is rendered. So for a calculated column, there is no filter context. And because there is no filter context available for sum to use, there's nothing to reduce the number of rows in the column. So sum just returns the sum of the entire column. Here, sum returns the sum of all the income for all clients. This means that we cannot do what we want using a calculated column. If we want to get the correct sum of fees, instead of using a calculated column, we need to use something called a measure. To create a measure, we'll click to select the income table. Then on the Table Tools tab, we'll click New Measure. And let's try the original expression we started with. We'll call it fee measure equals. As we're typing, the first problem we see is that IntelliSense is not showing our fields. If we keep writing the expression and hit enter, Power BI gives us an error. This is a pretty long error, so let's break it down. First part of the error tells us that Power BI doesn't know which value of amount to use because the amount column has many rows in the income table. The reason we're seeing this error is because a measure does not have a row context. In other words, it doesn't have any way to know which row we're referring to. The second part of the error tells us that a measure needs to use an aggregate function. This makes sense because we learned earlier that aggregate functions take into account the filter context. Since we need to use an aggregate function and we want to add up the fees, we'll try the sum function. Here again, we run into the same error we saw earlier. Sum requires a single column. And we already know we can't just add sum around each column because we don't want to sum the fee rate. If we try sum on just the amount and hit enter, we get the same error we saw before because the measure does not know from which row to get the income fee rate. At this point, it can start to feel like we've run out of options. We might wonder if we can even do what we're trying to do with DAX. The good news is there's always a way to do what we need to do if we just keep digging into the documentation. Because here we need a different function. We need to use something called an iterator function. In DAX, iterator functions go through a table one row at a time and compute the expression for every row, then they return an aggregate result. This concept of row-by-row calculation should sound familiar. It's what we talked about earlier when we introduced the concept of row context. By doing row-by-row calculations, an iterator function is reintroducing the row context. That's what makes iterator functions special. And that's exactly what we want because we need to multiply two values from each row, for every row in the table. Each aggregate function has an equivalent iterator function. The iterator function equivalent to sum is called sumx. Let's rewrite our measure using SUMX. The syntax for SUMX is slightly different, so we'll write SUMX. And the first parameter is the table, so we'll type income. And then the second parameter is our expression. When we hit enter, we see there are no errors. Before we add our new measure to our table visual, let's clean things up a bit by removing the last two columns. And now let's add our new measure. We see that the values match the values in our original calculated column. That's good, that's exactly what we wanted. But when learning DAX, even more important than getting the correct result is understanding what's happening. Let's break it down. Because this is a measure, it starts with the filter context. The filter context includes any filters or slicers, but also includes columns in our table visual, as well as any other visuals on the report. So here, we don't have any filters or slicers on our report. We do have client and fee rate in our table visual, and those make up the filter context. For example, we see two rows for client C. On the first row, we have income for client C at a 0% fee rate resulting in 0 fees. And on the second row for client C, we have income for client C at 2.9% fee rate resulting in $371.70 in fees. So the client column and the fee rate column are filters that Power BI applies when calculating the fee. One thing that can be confusing is that a row in a table visual is part of the filter context. Even though we call it a row in a table visual is not the same as a row in the base tables of the data model. When we refer to row context, we mean a row in a base table in the data model, whereas a row in our table visual here is part of the filter context. It's easy to confuse that concept, so it's important to draw the distinction. Back to our fees calculation. Now that we were able to create a measure to calculate our total fees, to get a better picture of how significantly fees are impacting the bottom line, we want to see the total fees as a percent of total income. This means we need to divide the fees by total income. To do that, first, we need to create a measure to calculate the total income. Let's create a new measure. We'll call it income sum measure equals sum of amount. And then add it to the table. Now that's not really what we want. This shows the total income for each client. What we really want is the total income for all clients. The reason this shows the total for each client is because this is a measure, and that means it's applying the filter context. As we said earlier, the client and fee rate columns are part of the filter context. So the measure is applying the client and fee rate columns as a filter before it performs its calculation. And then it's aggregating the income attributable to that client and fee rate. For example, in the first row, the measure applies the filter client A and the fee rate 0%, then adds up all the income for client A with a 0% fee rate and returns that amount in the first row of the income sum measure column. And that's not what we want, which means we need to figure out how to calculate the total income for all clients. To do that, we can use the SUMX function again. This time though, we'll combine it with the table function all. All is a function that forces Power BI to ignore filters on a table and return the whole table. Here, we'll use it to ignore the client filter and return the sum of all income for all clients. So we'll create a new measure. We'll call it income sum x measure equals sum x, and then we use the all function with the table income, and then comma, and then our income amount. Now, when we add that to our table, we see that our new measure displays the same value as the total of our income amount column. That's exactly what we want. Next, we'll create our percent of income measure. We'll call it fee percent of income equals, and then we'll use our fee measure and divide that by our income sum x measure. And then we'll add that to our table. Let's change that to a percentage. Now we can see how big of a bite fees are taking out of the total business income. We've looked at row context and filter context. And in this next video, we'll look at the most important function in DAX that actually converts row context to filter context in something called context transition. This is the calculate function, and you can learn how to use it by clicking this video right here. I'll see you over there.